Hello, ma'am. Myself, T. Kaushik Reddy of CSC B section. My roll number is 229518050, and my AAT Techtalk topic for Java or programming topics is memory management in Java. So let's start. So first of all, let's see what is memory management in Java. In Java, memory management is a process of allocation and deallocation of objects called uh, memory management. Java does memory management automatically. Java uses an ad automatic automatic memory management system called a garbage collector. Thus, we are not required to implement memory management logic in our application. Java memory management divides into two major parts. First one is the JVM memory structure, and the other one is working of the garbage collector. Next, JVM. Let's first learn about the JVM memory structure in Java. JVM creates various runtime data areas in heap. These areas are used during the programming execution. The memory areas are destroyed when JVM exits, whereas the data areas are destroyed when the thread exists. So this is the basic structure in the which is getting showed on the slide, like JVM memory structure. That is, which has method area, heap area, stack area, and the PC registers. Thread 1, thread n, stack frame, LVA OSFT, LVA OSFT, and the PC registers for thread n. Sorry, actually the PC registers for thread 1 to PC register for thread n. Native method stack. Next, method area. Method area is a part of heap memory which is shared among all the threads. It creates when the JVM starts up. It is used to store class structures, superclass name, interface name, and constructors. The JVM stores the following kinds of information in the method area. A fully qualified name of type X, example string. The types modifiers. Uh, Types direct superclass name. A structured list of fully qualified name of super interfaces. Next, heap area. Heap stores the actual objects it creates when the JVM starts. The user can control the heap if needed. It can be fixed or dynamic size. When you use a new keyword, the JVM creates an instance for the object in a heap. While the reference of that object stores in the stack, there exists only one heap for each running a JVM process. When heap becomes full, the garbage is collected. Next, when compared to stack, heap memory is larger in size. So, if we compare a stack and a heap memory, heap memory is large in size. The garbage collector automatically removes an unnecessary objects from the heap memory. So the basically the unwanted objects or the unnecessary objects are removed automatically by garbage collector from the heap memory. The heap's memory does not leave the contiguous. JVM gives the user the option to initialize or change the heap size as needed. The Java virtual machine throws an out-of-memory error whenever a calculation needs more heap than the automatic storage management mechanism can provide. Next, an object is given a place in the heap when a new keyword is used, but a reference to the same object already existing on the stack. So then the string builder, or you can say the syntax for the string builder, SP is equal to new string builder, open bracket and close bracket and semicolon. It is a statement actually. The above statement creates an object of the string builder class. The object allocates to the heap, and the reference SP allocates to the stack. Heap is divided into the following parts: young generation, survivor space, old generation, permanent generation, and the code cache. Next, heap is divided into the following parts. First one is young generation. Let's get the, you can say the deep definition about the young generation thing. All new objects are assigned and aged in this location. When this is full, there is a small garbage collection. Old generation, long-lasting items are kept in this location. Threshold for the object's age is specified. When it is placed in the young generation, and once it is met, the object is transferred into the old generation. Next, a permanent generation. This comprises JVM metadata for the application methods and the runtime classes. The you can say this is a program or a code. First comment for person class, next a public class person is an object, next a string first name, string last name, int age. Next, actually what is happening after the first three lines of the code? The comment constructor that takes first name, last name, and age as a parameter. Person string first name, string last name, int age. Next, an open bracket. This dot first name is equal to first name, then last name is equal to last name, then age is equal to age. Next, public static void main strings close square, open close square bracket and close square bracket args, or you get an argument, then open bracket, next and a comment, created an object of the person class. So without creating a object, there is no program in Java. So here an object is created. Person P is equal to new person John Doe, age 30. You can say the first string is John and the last string is Doe, and the age is 30. Next, just print all the three, like print first name, last name, and the age. So for printing, we use system.out.println p dot first name, next p dot last name, and p dot age. So after that, we get the print of the John Doe and his age to 30. Next, stack area. Stack area generates when the thread creates. It can be of either fixed or dynamic size. The stack memory is allocated per thread. It is used to store and partial results. It contains references to heap objects. It also holds the value itself rather than a reference to an object from the heap. The variable which are stored in the stack have certain visibility called stack area or the scope. Next, stack frame. Stack frame is a data structures that contain the threads data. Thread data represents the state of the thread in the current method. It is used to store partial results and data. It is also perform dynamic linking values written by methods and dispatching expectations. When a method invokes, a new frame creates. It destroys the frame when the invocation of the method completes. Next, each frame contains own local variable array, LVA, operand stack OS, and frame data. So here, each frame contains a different things, like it contains its own local variable array, OpenStack, OS, and the frame data FT. The sizes of LVA, OS, and FT determined at compile time. So basically, these are three things like LVA, OS, and FT are the sizes of these three are determined while compiling a program itself, not at a specific another time. Only one frame, the frame for executing method, is active at any point given thread of control. This frame is called current frame, and its method is known as a current method. The class of method is called the current class. The frame stops at the current method if its method invokes another method, or if the method completes, the frame get created by a thread is local to that thread and cannot be referenced by another thread. Native method stack. It is also known as C stack. It is a stack for native code written in language other than Java. Java native interface JNI calls the native stack. The performance of the native stack depends on the OS. Nothing but written in the last letter is operand stack. Next, PC registers. Each thread has a program counter PC registers associated with it. PC register stores the return address or a native pointer. It also contains the address of the JVM instructions currently being executed. So reference, value, reference, and the object array, then stack, then the heap. Next, garbage collector overview. So we get an what exact a garbage collector means. Let's get a view or overview on it. Then when a program executes in Java, it uses memory in different ways. The heap is a part of memory which objects live. It is the only part of the memory that involved in the garbage collection process. It is also known as a garbage collectible heap. All the garbage collection makes sure that the heap has a much free space as possible. The function of the garbage collector is to find and delete the objects that cannot be reached. Next, object allocation. When an object allocates, JVM checks the size of the object. It distinguishes between small and large objects. The small and large sizes depends on the JVM versions, heap size, garbage collection strategy, and platform used. The size of an object is usually between 2 to 128 KB. The small objects are stored in thread local area TLA, which is a free chunk of heap. TLA does not synchronize with other threads. When TLA becomes full, it requests for new TLA. On the other hand, large objects that do not fit inside the TLA directly allocated in the heap. If a thread is used, the young space is directly stored in the old space. The large object or the requires more synchronization between the threads. Next, what does Java garbage collector mean? JVM, a Java garbage collector, what is exactly it mean? JVM controls the garbage collector. JVM decides when to perform the garbage collection. We can also request to the JVM to run the garbage collector, but there is no guarantee under any conditions that the JVM will comply. JVM runs the garbage collector if it senses that memory is running low. When Java program requests for the garbage collector, the JVM usually grants the request in short order. It does not make sure that the request accept. Next, the point to understand is that when an object becomes eligible for garbage collection. So every Java program has more than one thread. Each thread has its execution stack. There is a thread to run in Java program that is main, open bracket close method, main, like main anything. Now we can say that object is eligible for garbage collection when no leave threads can access it. The garbage collector considers that object as eligible for deletion. If an program has reference variable that refers to an object, that reference variable available to leave thread, the object is called reachable. Next, here a question arises that can a Java application run out of memory? The answer is yes. A garbage collection system attempts to objects from the memory when they are not in use. Though if you are maintaining many live objects, garbage collection does not guarantee that there is enough memory. Only available memory will be managed effectively. Types of garbage collection: serial, GC, and parallel GC. Serial GC is nothing but in series type. Given that is mostly relies on a single thread, this is simplest GC implementation. Because of this, whenever this GC implementation executes, all application threads are frozen. Therefore, using it in multi-threaded application like server environments is not a good idea. Next, parallel GC. It is referred to as throughput collectors and serves as a JVM's default GC. It uses several threads as opposed to serial garbage collector to manage memory space, but it also pauses other application threads while doing GC. Next, concurrent mark sweep CMS collector. Multiple garbage collectors threads are used by the concurrent mark sweep CMS garbage collector to collect garbage. So the CMS collector employs more CPU than the parallel garbage collector to ensure faster application throughout or the throughput. The CMS garbage collector is recommended over the parallel collection if we can assign additional CPU for better performances. G1 garbage collector. The G1 garbage collector is made for programs that use multiprocessor computers with a lot of memory. It divides the heap memory into sections and performs parallel collection within each one. Just after reclaiming the memory, G1 simultaneously compacts the free heap space. However, it stops the world conditions. Next, conclusion. Memory management in Java refers to the process of allocating and freeing up space. Java memory management is divided into two major parts: JVM memory structure working for garbage collector. And the Java memory model explains how threads communicate with one another through memory in the Java programming language. The objects of the programming are stored in various locations in the JVM memory structure. Process of freeing space in the heap for the allocation of new objects is known as garbage collection. So this is the basic overview over memory management in Python, and as well as the garbage collection, how it is used in Java programming. So yeah, thank you. This is the end of the AAT Tech Talk for Java. That is topic memory management Python. Sorry, in Java.